Welcome friends. Today we shall learn the second lecture of Newton's laws of motions. Today the second chapter will be about friction and the numerical about it. What is friction and how does it work? Friction is a force which produced opposite to our external force. We force on some object in which direction, just opposite to it friction arises. So, at first, if this is a block of A of mass m, this is a block, if we applied a force externally on it in this direction to move it, friction arises tangentially over it in this direction automatically. If this is ground, if this block is placed on ground, then friction opposes the external force so that it cannot move. This type of friction, which is opposes the tendency of moving of object, is called static friction. Here the friction, static friction Fs acts to raise the body A, to stop the body A from moving it. There is another type of friction which is called motional friction or kinetic friction. If there are two blocks placed on a ground, B and C, this is C, this is B, then if we sliding C on B in this direction, then friction and force is around in this direction. If C is tends to moves, then it is static friction. If C moves with velocity v in this direction, then kinetic friction will arise just opposite to it. For static friction, the friction force automatically increase with external force, but there is a certain limit. It cannot increase infinitely. So, the limit of static friction is called limiting friction, is called limiting friction. And when the object is moves with velocity v, then the friction arises to decrease the velocity of C and becomes equals to B. That is, it opposes the motion of the body, which is called motional friction Fk. So, we know that frictions, the properties of friction is friction always acts opposes to the external force applied, and it acts tangentially on the surfaces. If the object is tends to move, then static frictions occur, and if the object moves, then kinetic friction occur in opposite direction to reduce its velocity. And other properties is, if this is the ground, then the weight mg is act downwards. Therefore, the ground also produce a normal reaction N which is directly proportional to the frictional force. That is, frictional force F S or K is directly proportional to N. Fs is equal to mu s N. Or for kinetic friction, Fk is equal to mu k N. Here mu s is called static frictional coefficient of static friction, and mu k is coefficient of moving friction or coefficient of kinetic friction. The value of mu s is greater than mu k. Now, we can derive some mathematical problem to understand the topic easily. This is the basic properties of frictions, and friction does not depend on the area of the contact surfaces. It does not depend on how much area is contact between B and C or other any object. So, let us take the example of mathematical solutions. A block A of mass 5 kg is placed on ground if we put a force if we pushed it by a force F is equal to 20 Newton with making angle 30 degree with horizontal, and if we pull it with a force F making 30 degree to horizontal, the two blocks are same. Here we push it or here we pull it. Here we push it making with a force 20 Newton, and here we pull it with a force 20 Newton with making an angle 30 degree with the horizontal. Now, what is the difference of acceleration between the two blocks when we push it and when we pull it? If the acceleration for push the block is A1 and the acceleration for pull the block is A2, then what is the difference between A1 minus A2 or A2 minus A1 depending on the value of A1 and A2? This is a question which is which came into the previous year joint examinations, joint entrance main. So, and also here the coefficient of friction between the ground and the block is given 0.2. So, we can now solve it. At first, we can draw free body diagram of the two. For this figure, figure A, if we draw free body diagram, this is the mass of the block, this force is F equal to 20 Newton, the weight is acting downwards, F is, this is 30 degree, so this force is F cos 30 degree, and the downward force is F sin 30 degree, the normal reaction acting upwards, and this is the frictional force. This is the FBD, free body diagram of the block where we can push it, For this, what is the free body diagram when we pull it? The free body diagram, if we draw the free body diagram, then this is the horizontal and the force acts 30 degree with the horizontal in this direction, 20 Newton. Then along this weight is occurred, along this direction also F cos 30 force is applied and force. Now, the F sin 30 force is along normal direction N. Here is the differences. So, the acceleration will be different. For pushing the object, the F sin 30 force acting downwards, and for pulling the force, pulling the block, F sin 30 force acting out upwards. This is the free body diagram of the two blocks in different situations. From here what we can get? From here we can get, if we take the equilibrium conditions, then we can get mg plus f sin 30 equal to n. M is given, m is 5 kg, m is 5 kg, and here take g is equal to 10, g is equal to take 10 meter per second square. Then f sin 30 for these pictures, f sin 30 plus mg is equal to n, and frictional force Fs is equal to mu into n, that is mu into f means 20 into sin 30 means half plus m means 5, g 10, and mu is given 0.2. So, this is the value of the frictional force Fs. This is the value of frictional force Fs. Now, this, if you calculate it, 50 plus 10, 60 into 0.2, that is 12 Newton. Fs is 12 Newton. Now, what is the net force? What is the acceleration and net force? Now, acceleration A equal to net force divided by mass. What is the net force? F cos 30 minus Fs by m, mass of the block. F means 20, cos 30 means root 3 by 2, minus value of Fn is solve out 12 Newton, divided by m is 5. Therefore, approximately 1 meter second to the power minus 2. It is get 1 meter second to the power minus 2 is the value of A1. Similarly, if we get the equation of A2, then what is the value? Here F cos 30, here F cos 30 minus Fs is also the net force, and n plus for this n normal direction plus F sin 30 equal to mg. Therefore, normal, what is the value of normal direction? mg minus F sin 30. What is the value of Fs? Mu into n, that is mg minus F sin 30 degree. Now, what is the value of effective force or acceleration? Net force, again F cos 30 minus Fs, that is mu mg minus F sin 30 by the mass of the block is 5. Therefore, if we consider the value of F is 20 Newton and putting the value of the whole quantity, then we can get approximately A2 equal to 1.8 meter second to the power minus 2. Therefore, the value of A1 is 1 meter per second square and the value of A2 is equal to 1.8 meter per second square. Therefore, what is the difference? A1 minus A2 or A2 minus A1? Because the A2 is greater than A1, is 1.8 minus 1, approximately 0.8 meter second to the power minus 2 is the answer. I hope you have all understood this. Simply we can get free body diagram and we can get the resultant force, and dividing by the mass we get the acceleration, and then simply we can difference it. This type of math is coming on, but will come in the next joint entrance examinations. Now we can go with the other example. We can go with some inclined plane. We all know the picture of a mass of an inclined plane. A block is placed on an inclined plane which makes an angle 30 degree with the horizontal. Now it is given that to be raised this block on this inclined plane, 2 Newton downward force is required. 2 Newton downward force is required. The maximum external force up the inclined plane does not move is 10 Newton. Therefore, there are two situations. Situation 1 and situation 2 said if the block remains stopped or remains stationary on this wedge, then upward force is required 10 Newton. Understand this. The block of mass, suppose M, is placed on an inclined plane. If the block remains stationary, then force required downward direction is 2 Newton, but upward direction is 10 Newton. 10 Newton. Coefficient of friction of the block is say to find out what is the value of coefficient of friction mu. How can we solve it? What is the value of mu? If there are given 4 value, we can put out the right answer. Then what is the value? For this type of equations, we can find out first free body diagram, that is separate situations is occurred. Let us take with the first situations. Situation 1. This is the, for inclined plane, mass is acting along this direction, and if this is 30 degree, this is also mg cos 30 degree. What? Why? Because this is, if we take this is 60 degree and this is 30 degree, because this is the perpendicular force. If we draw this, then this angle is 90 degree, then 90, 30, 120. This will be 60 degree, and this is also mg cos theta is perpendicular to the plane. Therefore, this is 90 degree and the force which balances is the normal direction n. Therefore, in this direction the force is mg sin theta, and of course the friction acts along opposite side fs. This is the free body diagram of situation 1. Therefore, if we balance the force, what we can get, as the blocks remains stationary, therefore acceleration 0. Acceleration 0 means force are in equilibrium, that is the net force acting on the block is 0. Therefore, 2 plus mg sin 30 is equal to fs. 2 plus mg sin theta acts along this direction is equal to Fs. And what is Fs? 2 plus mg sin 30 equal to mu n. What is n? mg cos 30. This is the first equation we can get. 2 plus mg sin 30 is equal to mu mg cos 30. Now, from this picture, what we can get? Here 10 Newton force is here and also frictional force is along this direction. Only this direction force mg sin 30 occur, and this is mg. So, this angle is 30 degree also. This is mg cos 30, and normal reaction is acts opposite to it. Therefore, in this picture mg sin 30 is equal to Fs, that is mu mg cos 30 plus 10. mg sin 30 is equal to mu mg cos 30 plus 10. This is the equation 2. Now, if we solve these two equations, 2 plus mg sin 30, if we put the value of mg sin 30, mg cos 30 and solve it, then we can get two equations. Solving equation 1 and 2, we get two equations. I know you can solve it easily. So, I can write down as mg sin 30 equal to 4 and mu mg cos 30 equal to 6. We can get equation 3 and equation 4. By solving this, we can get these two equations. Now, divide equation 4 by 6. If we divide equation 4 by 3, then what can we get? mg cancel, mu cot 30. Then if we 4 divided by equation 3, we get mu cot 30 equal to 6 by 4, that is 3 by 2. Then what is the value of cot 30? Tan 30 means 1 by root 3, that is cot 30 is root 3 equal to 3 by 2. What is the value of mu? What is the value of mu? Mu into root 3 is equal to 3 by 2. Then what is the value of mu? Mu equal to, here we can write mu equal to 3 by 2 into root 3. If we cut a root 3, that is mu equal to root 3 by 2 is the answer. Mu equal to root 3 by 2 is the answer. This type of equation of motions, considering kinetic friction, we can solve it. Here two different situations will occur. I hope you understand it. Depending on the free body diagram, we can easily elaborate it. Now, next question. This is ground, two blocks A and B, this is B block and this is A block, are placed on it. Two blocks A and B of mass Ma equal to 1 kg, mass of A, mass of Ma equal to 1 kg and mass of mb equal to 3 kg is placed on ground. The frictional force acts between B and ground is 0.2 and also between A and B is 0.2. The maximum force F that can be applied on B horizontally so that the A does not slide out. Find out the value of F. Two blocks A and B are placed on ground. The A is top of B. Now we can give a force F horizontally and if we put force F in this direction, A will be slided along this direction. It generally occurs. But here the question asks that what is the value of F, maximum value of F, so that the A does not slide. If A slide, then the problem goes out. Then what is the value of F? That A does not slide out. Coefficient of friction between ground and B is 0.2 and A and B is 0.2. What is the value of maximum value of F? Now, if force F is applied, then a frictional force acts along this direction, F1. Then what is the net pulling force? And what is the acceleration of the system? At first we find out the acceleration of the system. A. As we can say in the earlier classes that acceleration is net pulling force by total mass. What is the net pulling force? F minus frictional force F1 by total mass of A plus mass of B, that is F minus. Now what is the value of F1? F1 is mu n. That is F1 equal to mu n. And what is the value of n? N is equal to mass of Ma plus Mb into G. That is F1 is equal to mu into Ma, mass of A, mass of B into G. If we put the value of mu into Ma plus Mb into G divided by mass of A plus mass of B. Mass of A plus mass of B. Therefore, A is equal to F minus mu 0.2 into Ma plus Mb 2 plus 1. Mass of A 1 kg, mass of B 3 kg. Sorry, 3 plus 1, that is 4. That is 4 into G equal given 10. That is 4 into 10. G equal to 10. The 0.2 into 4 into 10 by 3 plus 1, 4. That is F minus 8 by 4. This is the equation number 1. The whole acceleration, the acceleration of the whole system is A equal to F minus 8 by 4. What is F? F is the maximum value of the force which is given to B so that A does not slide over it. How can we? Now A equal to F minus 8 by 4. Now here a twist occurs. What is the twist? Now when we can apply a force F on it, a pseudo force will occur which slide the A in this direction. A pseudo force is occur and the friction between B and A occurs in this direction, which is given by F2. A pseudo force will occur which pull the A towards it. If we give B in this direction, a frictional force pull a pseudo force will pull A during this. And what is the value of pseudo force? F dash equal to MA into A. MA into A. Now for sliding down it, the F dash greater than F2, for sliding down it, the block A, for sliding the block A, the pseudo force F dash must be greater or equal to frictional force between A and B. F dash must be greater than frictional force A and B. Now F dash equal to MA greater or equal to F2. Greater or equal to F2. What is value of F2? Mu, here only A, friction is only A into G, that is MA into A equal to mu MA G. But here we does not want to slide the A, so there is limiting friction occur. For limiting friction, this force, that is MAA, must be equal to mu MA G. MAA equal to mu MA G. We can get out the value of A, that is cancel MA, that is mu upon G, mu times G. Mu is 0.2 into G is 10, that is 2 meter second to minus 2. A equal to 2 meter second to the power minus 2. Putting the value of A in this equation, 2 equal to F minus 8 by 4, F minus 8 by 4, that is we can get F equal to 4 into 2 equal to 8 plus 8, 16 Newton. So the maximum value of force applied on B is 16 Newton, such that so that the A does not slide over it. I hope you understand. Very good. A pulley is hanged along this. Here a pulley is given, a mass M is hanged from it, and here is also a pulley is given, from which a mass of M is also hanged, and from these two a mass root 2m, here M and here root 2m mass is hanged from it. Now this is theta and this is also theta. Now what is the value of theta so that the system is remains in equilibrium? System is remains in equilibrium, that is no force applied on it, or the net force applied on is 0. What is the value of theta? So for this type of questions, pulley number 1, pulley number 2 and another mass is hanged from this. the system remains in equilibrium for a certain value of theta. How can we find the value of theta? We can consider the free body diagram separately. If we consider the free body diagram of M, the mass mg is along this and tension T acts towards away from this, that is T equal to mg. For this mass mg free body diagram, we can get T is equal to mg, number 1 equation. Now, if the tension is T along this and tension is T along this, what is the value of the component of T along this? T cos theta, and for this T also T cos theta act, therefore the net force is 2T cos theta, and along this T sin theta acts along this direction, along this T sin theta acts along this direction. As the two forces are equal but their direction are opposite, they will be cancelled out, and here the mass root 2 mg occur. Therefore, for this root 2 m masses, the free body diagram is 2T cos theta equal to root 2 mg. 2T cos theta is equal to root 2 mg. If we divided equation 2 by 1, then T cancel, 2 cos theta equal to mg cancel, root 2. Therefore, cos theta equal to root 2 by 2, that is 1 by root 2. Now, cos theta is equal to 1 by root 2 means theta equal to 45 degree. Therefore, we can get the value of theta equal to 45 degree, so that the system remains in equilibrium position. Now, this way we can understand the numerical problem of friction. I hope you understand this. For the next time, we can get some more interesting topics on the physics for both 11, 12 and joint entrance. Thank you for watching my video.